In this lecture, we are going to discuss the last two sections of the chapter 5, which are the multiplication of the special products and the division of polynomials. If we apply the special product rule, it's easier to find the product of some polynomials. And the first special product we had is the sum of difference. And let's first try to multiply terms that have the same terms, but in one term we had the sum and the other term we had the difference. Like in this case we had a plus b and a minus b, and then we will try to find the root. Then let's multiply in the way we learn. We will multiply then using the FOIL lines right now. Then if we use the FOIL, we multiply the first terms and we multiply the outside terms, we multiply the inside terms, and then the last. And we can say this equals to a times a is a squared. A times minus b is minus ab. A times b equals to positive ab. And positive times negative is negative b squared. B times minus b is minus b squared. Then now we need to combine terms. Then what happens is in the middle terms, we had minus ab plus ab. Then this will cancel out. Yes, they are the same. They are opposites. Then yes, we had minus b squared. And let's see what happened in our second example. And we had the same case. We had the sum and the difference of the same terms. Yes, we had x, we had a. Then now let's multiply also in the way we know using the FOIL method. Then we multiply the first terms, the outside terms, the inside terms, and the last terms. Then we had x times x will be x squared. A times minus x times minus a will be minus ax. A times x will be ax. Positive a minus a will be negative 64. Now we need to combine terms, and then what we can see is we had opposites again. Yes, minus ax plus ax, they cancel out, will be 0. And finally we had x squared minus 64. Now let's see what happened when we had the sum of different of the, we had the product of the sum and different of the same terms. And what happened is in both cases the middle terms cancel out, and just we had the square of the first term minus the square of the second term. Here again, the middle term cancel out. Just we had the square of the first term minus the square of the second term. Then now we can write, we can express what is the rule we can apply. Yes. Then if we had the sum and difference of the same terms, then how we can write the solution? Yes, we need to square in the first term. We had x, we had to square in the first term and square in the second term. Yes, we need to square in the second term and put in the subtraction symbol between them. Yes, we need to write the negative symbol between them. And this product apply only if we had the sum and difference of the same terms. And this rule apply also if you had this problem. Yes, if you had x, yeah. If the difference of the both terms is is first and then is the sum is also the same case. Then we can apply the rules also in this case. And if we need to solve this one, we will say because I had the sum of different of the same terms, then this, I know this with the square of the first one, negative sign in between the square of the second term, means this will be minus 64. And let's try to solve this problem applying the rule, yes, applying the rule, the sum of difference rule. And the first thing we had to check if we had the sum and difference of the same terms. We had x, we had 5. Then we can apply the rule in this case. Then equals the square of the first one, yes, negative sign in between the square of the second term. And this equals to x squared minus 25. And it's okay if you skip this step, as you can go ahead. If you don't get confused, move to the first to the last step. And let's try the second one. And to apply this rule, we need to check always if we had the sum and difference of the same terms. When we had sum, we had difference. Yes, we had sum here, we had difference. Now we had 3x, we had 7, and we had 7. Then yes, we can apply this rule. Then what we had to do is to square the first one, negative sign in between, and the second, we need to square in the second term. 3x to the second power, 3x, then we need to square in the number. 3 to the second power is 9, x to the second power is x squared, negative 7 to the second power is 49. And this is the answer. The last term, yes. Then we need to check here. We had the sum of different of the same terms, yes, 1, 1, 4, p. Then we had the sum of different of the same terms, then we can apply the rule. And this one will be just the square of the first one, negative sign, squaring of the second one. 1 to the second power is 1, 4p, and 4 to the second power is 16, p to the second power is p squared. And this is the answer. Yes, then we can apply this rule, and we can find in easy way the product of this kind of polynomials. The second special product we have is the perfect square. And the perfect square is some term like a plus b squared or a minus b squared. Then we will do the same to find the rule. First, let's multiply in the way we know, and then we will try to find the rule. Then we will multiply this. We will try to find the solution for this perfect square using applying the FOIL method. Then a plus b squared. Then we know we can express this one, yes, because it's to the second power. In this case, the base is a plus b. Means we need to multiply a plus b twice because it's to the second power. Then we can rewrite this one like a plus b times a plus b. Now, if we apply the FOIL, then we have the first, and a times a is a squared, a times b is ab, positive, a times b is ab, b times b is b squared. We can combine the like terms. Then we had ab plus ab, we had 2ab plus b squared. And this is the result if we multiply using the FOIL method. And we can do the same in this case. Let's try to solve this one using the FOIL method. Then if this, in this case, the a minus b is the base, because it's to the second power, we need to multiply twice. Now let's apply FOIL method. And we multiply this one will be a times a will be a times minus b will be minus ab. Minus b times a will be minus ab. Negative b times negative b will be positive b squared. Now we combine the like terms and both are negative. We add the numbers together and the answer is negative. The negative ab will be negative 2ab plus b squared. And we had this too. And what we can see in both cases, if we had perfect square, we will have the square of the first term, yes. Then we had twice the first term times the second, yes. Twice, in both cases, we had twice the first term times the second, and the last term is the square of the second term, yes. This is we had in the last. Yes, we need to be careful with the signs. If the sign in between the terms is positive, then all the terms in the answer are positive. If the third in between the sign in between the numbers, the sign between the terms is negative, then the first sign always is negative. Just this sign is negative. The other is always positive. Yes, the second one, the first sign is negative, and the second sign is always positive. Then, if we had perfect square like this one, how we can solve? Yes, we can say the square of the first term. Yes, if it's positive, will be plus twice the first term times the second term. Yes, twice the first term times the second term, plus the square of the second term. Yes. If this is negative, just we change the first term, as this is only we had to do. The other parts are the same. And let's try to apply this rule to solve some perfect square without multiplying, without applying the FOIL method to get the answer. And then we have these two problems, and let's apply the perfect square rule. And if we had x plus a to the second power, then what we can do equals. Then we can apply the perfect square rule. We will say is the square of the first term, because it's positive, we know this sign must be positive, twice x times the second term, twice x times a, plus square of the second term. Yes. Now just we solve this one will be x squared, 2 times a will be 16x, a to the second power equals to 64. And this is the answer. Now let's apply the same rule for the problem we had for the second problem. We had perfect square, but this is negative. Then we need to square the first term. We know it's negative. Negative sign must be here. Twice the first term times the second. The second sign is always positive. Square of the second term. And we had x squared negative 2 times a will be 16x. A to the second power is 64. And this is the answer. Now let's apply the same rule to these two problems. Then we had 5x plus 7 to the second power. Then we had perfect square. Then let's now try to get the answer. Then we need to square the first term. In this case, the first term is 5x. Then this is why we had to square 5x. It's positive. We know here must be positive. Twice the first term, which is 5x, times the second, times 7, the second one, plus square of the second one. Now let's multiply 5x to the second power will be 5 times 5 will be 25 x squared plus 2 times 5 is 10, 10 times 7 is 70 x. 7 to the second power is 49. And this is the answer. Then we had perfect square, we had the negative sign in between. Now we can apply this rule. Then here the first term is 3x. The second term is 5. Yes, it's 5. Then we need to square the first one. Minus, because we have negative sign here, twice the first term times the second, plus square of the second term. And 3x squared will be 3 times 3 is 9 x squared. 2 times 3 is 6. 6 times 5 is 30 x plus 25. And this is how we can apply the rules to solve special products in an easier way. And now let's move to the next section, which is division of polynomials. Then the first thing we want to learn is how to divide polynomials by monomials. And to divide polynomials by monomials, we divide each term in the numerator by the denominator. Yes. And we want to solve problems like that. We have polynomials here, and here the monomial is just one term. And what I want to do is I want to write this one again, a plus the problem is like that. Now we divide each term in the numerator but by the denominator. Then we need to divide a divide by 4x to the third plus 4x to the 4 divide by 4x to the third plus 12x to the third divided by 4. Now what we had to do is we need to divide the numbers, and in case of the powers we need to apply the properties of the exponents. And a divided by 4 equals 2x. Then just for this problem I will write step by step, but the next problem is just we will write the answer. Then in this case we had to subtract the exponents. It will be 6 minus 3 plus 4 divided by 4 is 1. You don't need to write if you don't want, but let's write this time. X 4 minus 3. Yes, we need to subtract the, because we had division, then we need to subtract the exponents. 12 divided by 4 is 3x. You see we had x to the third, x to the third, and you can solve this in two ways. You can say just I can cancel out and no x here, or you can say apply the same rule. 3 minus 3. And we know 3 minus 3 equals to 0. Yes, to 0. And any number to the 0 power equals to 1. And finally, it's 2x. 6 minus 3 is 4. We don't need to write this one. X. 4 minus 3 is 1. We don't need to write 1. 3. Then x minus 3 is x to the 0 power. Finally, you can write this one like 2 plus x plus 3. Remember, x, I will write here, x to the 0 equals 1. Then you can solve in that way, but also just you can say 12 divided by 4 is 3, and the x to the third, they cancel out. Then no x, yes, no x in this case. Then you can solve in either way. Then I show here is just to review how we need to divide terms which have exponents, but in the next problems, just we will go directly from this step to this step. Okay, and remember, just we need to, if we had the division of the powers, what we need to do is we need to subtract the exponents. But we have to be careful is the bases, the base, in this case x, must be the same in order to apply that rule. And in this case, this is the answer. And let's move to the next. Nine. And in this case, we have 9x to the 5, 6x to the 4, x 24x to the second divided by x to the second. And now we divide each third in the numerator by the denominator. The second plus 6 divided by 3x to the second. Let me write this. And let's now try to skip some steps. 9 divided by 3 is 3. X, we need to subtract the exponents. 5 minus 2 is 3. Plus 6 divided by 3 is 2. X, 4 minus 2 is 2. 18 divided by 3 is 6. X, 3 minus 2 is 1. We don't need to write the 1. 24 divided by 3 is 8. Then it's up to you. You can say, just cancel out, or x, 0, 2 minus 2 equals to 0. And finally, 2 because we know x to the 0 power equals to 1. Or again, yes, you can say this cancel out, and we have just 8. Yes, will be easier probably just to say that. Then let's now solve the next problem, and we will apply the same procedure. Right here equal 4 x to the third, and we divide each term to the third divided by 4 plus 2 second. And now 20 divided by 4 is 5. X, 4 minus 3 is 1. We don't need to write 1 here. Plus. And x to the third, they cancel out, but we have to be careful, yes, because 4 is in the denominator, it's not on top. Then what we had finally here is 1 over 4. Yes, 4 is in the denominator. Then x to the third and x to the third, they cancel out, and we have 1 over 4. Now we need to simplify, we need to reduce this fraction. We had 2 over 4, 2/4. Then when we can reduce, we can divide by 2. Yes, 2 divided by 2 is 1. 4 divided by 2 is 2. Then we reduce the fraction, if in this case, if it's possible. And now we need to subtract this one, will be 2 minus 3 will be minus 1. Yes, will be 2 minus 3 will be minus 1. But we don't want negative exponents in the answers, then we need to write this one including just positive exponents. Then what need to do with this? If we had negative exponents, just flip it. And then 1, 2 is on top, just win. And x to the first power, but we don't need to write to the first power. And this will be the final answer. Now we want to learn how to divide polynomials by polynomials. And when we divide polynomials, this works very similar in the way when we divide whole numbers. Then to review this procedure, then let's first divide numbers, and then we will try to apply the same procedure to divide the polynomials. And let's divide first 631 divided by 4. And let's write this one like 631 divided by 4. And the first thing we want to do is we need to do is to see how many times does 4 go into 6. Then it's just one time. Then 1 times 4 is 4. Then we subtract here 4. Then we say 6 minus 4, 2. Now the next thing we have to do is we bring the 3 down. And now we start the procedure again. Then we need to see again how many times does 4 go into 23. Then it's 5 times. Then we say 5. 5 times 4 is 20. 5 times 4 is 20. Now we need to change the sign. And we combine these two. 23 minus 23. Now we repeat the procedure again. We bring the 1 down. Then now again, how many times does 4 go into 31? Is 7 times. And we multiply 7 times 4 is 28. We change the sign here. We combine the numbers. We subtract the numbers. 31 minus 28 is 30. Because now the remainder is less than the divisor, and just we stop the division. And now we can write the answer. Yes, we can write the answer. Then we can say this equals to 157. Then in the numerator we need to write the remainder, will be 3, and in the denominator we need to write the divisor because it's not exact number. We had remainder, then we need to write this one. We need to write the remainder here, and this, the number is in front, is the quotient. The number is in the denominator is the remainder, and the number is in the denominator is the divisor. And let's review the steps we did in this procedure. When we divide the front terms first, yes, 6 and 4, we divide the front terms, yes, 6 divided by 4 is 1. Then we multiply this term 1 by the divisor, yes, we say 1 times 4 is 4. We change the sign here, and we combine these two numbers, 6 minus 4 is 2. We bring this 3 down, and then we repeat the procedure. And we will follow the same procedure when we divide polynomials. In this case, we want to divide a trinomial divided by binomial. Yes, 3 terms, and here we have 2 terms. And the procedure we want to follow is the same. Just in this case, because when we divide polynomials, yes, when we divide the terms are a little more complicated, then I will write down all the steps, all the divisions we had to do. And let's now take x squared for x divided by x minus 8. And let's start. And the first thing we had to do is we need to divide the front terms. Yes, we need to divide the front terms. What are the front terms in this case? X squared and x. Again, because now we had variables, we had the exponents. And let's write all the steps. X squared divided by x. Divide the front terms, and x squared divided by x is x. Yes. Then we'll write here x. In this case, this is the 1. Yes? Now we need to multiply x by x minus 4. In the same way we multiply 1 times 4. And let's write down this one here, x minus a, x squared minus ax. The next step we have to do is we need to change the sign and combine. Yes, we say 1 times 4, and then we change the sign 4. And in this case, we say x times x minus a equal this one. And now we need to change the sign. We had x, change the sign. We had negative ax, change the sign. Combine. This term cancel out because we had opposites. Then negative 4x plus ax, let me write here, ax equal to 4x, positive 4x. Bring the negative 38 down, and we need to start the procedure again. I will just start the procedure again. Divide the front terms. 4x divided by x. 4x divided by x. X cancel out, and we have 4. We'll write this one. Because 4 is positive, we will write plus 4. Now multiply 4 by x minus a. In the same way, we multiply 5 times 4 in the normal division. Then now we multiply 4 times x minus a. And 4 times x is 4x. 4 times negative a is negative 32. X. Change the signs. Negative, we need to change to positive 32. Combine the terms. Negative 38 plus 32 is negative 6. Once you don't have any variable in the remainder, then you in that point you stop the division. Just stop the division. Now we need to write the answer, and we will write the answer in the same way we wrote the answer when we divide numbers. And in this case, this is the remainder. This is the divisor, and this is the quotient. Then let's write the answer in the same way. Then equals, as we have equals here. The quotient is the whole number. Yes, quotient is the whole number. Is in this case was 157. In our case, was x plus 4. X plus 4. Now we need to write the remainder, yes, the other part. And we had negative 6, and we write here negative 6 is in the numerator, and in the denominator will be the divisor, which is x minus a. And this is the answer. Yes. This, then if we divide if we divide these two polynomials, then we got x plus 4 minus 6 over x minus 8. And maybe here let me write something like that to know this is the answer. Yes, to know this. This is the answer. And let's try to apply the same concept to this problem. And we want to divide this trinomial divided by this binomial. And let's write first x squared plus 30x plus 32 divided by x plus 5. And the first thing we want to do is we want to divide the front terms. Yes, we had here, we divide the front terms. Then x squared divided by x. Then we write this in the quotient. We multiply this term by the divisor. This is the second step. We multiply this term by the divisor. And let's multiply this one here. If you don't need to write, it's okay. But I prefer to write. This way you avoid any mistake. And x times x is x squared. X times 5 is 5x. Now we need to change the sign of the third and combine. We had x, that's negative x squared. Negative 5x. Combine. Cancel out. 13 minus 5 is 8x plus 32. This is an 8x. Then we bring the 32 down and we start again the procedure. Then we divide the front terms with the ax. Yes, ax divided by x. 8. We multiply, right here a, we multiply a by x plus 5. And a times x is ax, a times 5 is 40. And now we change the sign, of the third and combine. Then we have ax, we need to change to negative ax. We have plus 40, we need to change to minus 40. Negative 8. Now there is no any variable in the remainder, then we stop in this point we stop the division. Now we need to write the answer. Yes, we need to write the answer, and we need to just to remember this is the remainder, the divisor, this quotient. And now we need to write here the answer. Is the quotient first, yes, the whole part is x plus a. Now we need to write the remainder, then will be negative 8 divided by the divisor, x plus 5. And this is the answer. Yes, x plus 8 minus ax divided by x plus 5. One thing we can see here is in all the cases the term is in front is cancelled out. If this doesn't happen, you see here x squared and x squared, they cancel out, ax cancel out. If this doesn't happen, then something is wrong when you are solving the problem. This term must be cancelled out. If this term doesn't cancel out, you are doing something wrong in the procedure. In this problem, we want to divide this polynomial, which has 4 terms, divided by the binomial. And let's follow the same procedure we learned, we applied before. And 3x to the third, 5x to the second, minus 32x plus 7 to divide by x minus 4. And let's now start the division. And now we divide the front terms is 3x to the third divided by x. Then 3 divided by 1 is 3x. 3 minus 1 is 2. Here we need to write 3x to the second. Now we need to multiply these two numbers, 3x squared times x minus 4. Then 3 times x, 3x squared times x is 3x to the third. 3 times negative 4 is negative 12x squared. And we multiply this term times the divisor. Now we change the sign of the third and combine. Then we have 3x to the third power, we change the sign. We had negative 12x to the second, we need to change the sign. It's positive 12x to the second. Now, as we can see, always this term must be cancelled out. And this cancel out, we have 12 minus 5 is 7x to the second. Bring the next term down, and we start again the procedure. Divide the front terms. Then the front terms, they are 7x to the second divided by x. And this, let's write this one here, 7x to the second divided by x. Then 7 divided by 1 is 7, x. 2 minus 1 is 1, then it's 7x. Then we write this one here. Now we multiply 7x times x minus 4. As we did one, we multiply this number by the divisor. Then 7x times x minus 4. And 7x times x is 7x to the second. positive times negative is negative. 7 times 4 is 28x. The next thing we had to do is we need to change the sign and combine. Then 7x to the second, change the sign. Negative 28x will be positive 28x. As we can see, this term cancel out. Then negative 32 plus 28 is negative 4x. And we bring the 7 down and we repeat the procedure. Then now the front number will be negative 4x, and if the number is negative, we need to write the sign. It's negative 4x divided by x. Then negative 4x divided by x is negative 4. And we need to write here negative 4. Now we need to multiply negative 4 by times x minus 4. Yes. We multiply now negative 4 times x minus 4. Then will be negative 4x. Negative times negative is positive, and it's positive 16. Now the next thing we want to do is we want to combine, but to do that we need to change the sign. Yes, we need to 4x. Now this is positive, then we need to write here negative. As we can see, this term cancel out, and finally we had negative 9. There is not any variable in the remainder, then now we stop the division. Yes, now we need to write the answer. And just remember what we had to write here. First is the quotient, which is this one. Yes. Let me write this one again. Is the quotient. Remainder. And we know this one is the divisor. And first the quotient will be 3x to the second plus 7x. Let's see if I can write better here. 7x minus 4. Now we need to write the remainder. Then with negative 9, the remainder, we need to write the remainder in the numerator, and in the denominator the divisor, and x minus 4. And this is the answer. Yes. 3x squared plus 7x minus 4 minus 9 over x minus 4. And this is the answer. And this is all I had for today.